Hey guys, welcome to Carry Academy. We're going to start chapter 4 and we are going to do it on video. Alright, and we're going to start going through section 4.1 together. Alright, chapter 4 deals with congruent triangles, so next couple chapters we're going to be diving full force into triangles and everything about them. Reason we're doing Carry Academy is section 4.1. It's really just a lot of terminology, classifying triangles. So we'll be going over what is a triangle and what are its parts. And then we'll also be talking about how we classify triangles, specifically two different ways. How do we classify them by their side measures, their side lanes, and how do we classify them by their angle measures? Okay, so those two things are going to be used to classify some of the triangles we look at today. Alright, so let's start running through this quick. Alright, here's a triangle. Right? This is triangle ABC. So it's named very easily with the three vertices that are on that triangle, or the 3 points that are used to connect to make the triangle. So that is triangle ABC. The notation you'll see for a triangle is just actually a little triangle symbol like that, and it'll say triangle ABC. Right? So that's how we name a triangle. Right. Now we know triangles are three-sided polygons, so they have to be enclosed figures. That's what makes them a polygon. All triangles only have three sides. Right. Now here's the different parts of the triangle. Triangles all have sides. Right. Those sides are segments. So we have three segments here that make up the triangle: segment AB, segment BC, and segment AC. Okay. Now, just like there's three sides, we have 3 points, which we call vertices, that make up the triangle. All right, now I'm going to stop right there. The reason I call vertices is just poor text for vertex. All right, so same thing like in an angle, where the two sides of an angle come together at the vertex. The sides of a triangle come together at vertices. All right, so the 3 vertices here are just naming the points. Points A, points B, and point C. And then the angles in the triangle, right, they can be named two different ways. We first have angle BAC. So remember, the vertex is always named in the middle. So I'm going to highlight in orange. We have BAC, that little angle there. We could, since there's only one angle that comes off of vertex A, we could just call it angle A. But you might see it written as BAC. In green, we have ACB. We could just call it again angle C. And then in yellow, we have angle CBA, or just simply angle B. Okay, so 3 sides, 3 vertices, 3 angles formed in every triangle. All right, so how do we classify them? Well, the first way we can classify triangles is by angle measures. So the first type we have is an acute angle. Right? And I would highly suggest pausing this video if you have to write these down. These are 4 classifications that you'll need to know. We will be doing probably a Kahoot next class, just so I can check to see that you guys can classify these triangles. So acute triangles, simply 3 acute angles. All of the angles in an acute triangle are acute. So for instance, we know the angles inside a triangle have to add up to 180 degrees. So you might have one that's 50, one that's 70, one that's 60, right? All acute angles, so we have an acute triangle. Equiangular triangle, right? Tongue twister there. 3 congruent acute angles, right? Now the only measure that can be within an equiangular triangle is 60, because if they're broken up evenly, 180 divided by 3 is 60, so it would be a 60, 60, 60 degree triangle. An obtuse triangle has one obtuse angle, right? So if you look at the picture, it clearly appears like this is your obtuse angle, right? The reason there can only be one obtuse angle, if it had 2 obtuse angles, right? Say like an angle like 91 and another one, hypothetically that's 91, that would put you over 180 degrees, so therefore it could not be a triangle anymore. All right, so 2 triangles will only have one obtuse angle. Right? And then a right triangle, we all know, has a right angle within it, and you will always have our little box symbol to indicate that it is a right triangle. It has to tell you that, otherwise you cannot assume. Alright, so let's take a look at this example. If I gave you this diagram and I said I want you to classify triangle PQR by its angles. Alright, let's take a look at the three angles that make up triangle PQR. Well, first we have angle P. We'll do in red. Angle P, 45 degrees. It is acute. Right. It automatically cannot be an equal angular triangle because all angles would have to be 60. Then we have angle R. Angle R, 31 degrees, also acute. Right. Now, triangle PQR, the entire figure, right? So our angle Q right here is really made up of two angles. You have angle PQS, which is 45, and angle SQR, which is 59. If we use angle addition postulate, that whole angle has to be 45 plus 59, or 104 degrees, right? Since there is one obtuse angle, we would say it's an obtuse triangle, okay? So triangle PQR classified by angle measure would be an obtuse triangle. All right, so that's how we classify by angles. Now, how do we classify by sides? Right, these are probably terms you've heard of before. Here's our little diagram. Again, if you have to pause to write these down, I would highly suggest it. First, we have an equilateral triangle. Right? I'm sure most of you have heard this term before. It is three sides that are congruent. Right? You'll be able to tell that it's an equilateral triangle because you will have your tick mark. So every side has one tick mark. We all know they're congruent sides. Therefore, it is equilateral. An isosceles triangle will have at least two congruent sides. Right? So if you take a look, both of these sides have two tick marks. So those two sides are congruent. Since we have no tick marks over here, we can't assume anything about that side. So we know there's at least two congruent sides, so we'll call that an isosceles triangle. Scaling, going to have no congruent sides. So hypothetically, we could have a side that's 5 units long, one that's 7 here, and maybe this one is 11 units long. Right? No side measures that are in common, so it would be scaling. Okay, so those are the three that you need to know, and those are strictly classifying by sides. All right, so let's take a look at the last example. Right? If we want to classify this triangle by sides, right, we're going to say if M's the midpoint of segment JL, so I'm just going to highlight the midpoint right here. Okay, we want to classify triangle JKM, so I'm going to highlight triangle JKM. We want to classify that triangle as equilateral, isosceles, or scaling. Okay. Well, if we look over here, we already have two tick marks. Right? So we know segment KM and segment ML are congruent to each other. Okay? But since it tells us point M is the midpoint of JL, this bottom segment, right? We know ML and JM have to be congruent, so therefore we're going to have to put a tick mark there as well. Right? So now let's split this up. JL, it gives us the entire length is 1.5. If we split that in half evenly, we know JM's 0.75. ML, also 0.75. Okay. Since we have a tick mark up here for KM as well, it's got to be the same length. That's going to be 0.75. Right. So now if we look at the triangle that I highlighted, JKM, each side length is 0.5 or 0.75 units in length. They are all the same. Can't spell today. Right? We have an equilateral triangle. Okay? So those are the type of problems you might see. Right? Just use classify. Pretty simple. If you know the definitions, you'll be able to classify any triangle. Right? Again, that's why I wanted to show you guys this video. That way you guys could just be familiar with them, and then we'll jump right into classifying them with a little warm-up and then move on to section 4.2. All right? I will see you guys next class. Hope you enjoyed. Right? And Have a good rest of your night.